Okay, we're going to look at number 12 in section 3.1. We're going to use the limit definition to compute the derivative of the function f of t equals 2 divided by 2 minus t at t equal -3. Okay, so in anticipation, I know I'm going to need f of -3. So I'm going to plug in t, replace t with -3. I get 2 divided by 5, 2/5. I also am going to need f of a plus h, right? And a being -3 in this case, since we're finding the derivative at a. So I've got f of -3 plus h is 2 divided by 2 minus, I replace t with -3 plus h. Be sure that's in parentheses so that I can distribute this negative sign through, and we get 2 minus a -3 plus 3 minus h. 2 plus 3 is 5. I get 2 divided by 5 minus h. So here is the output when I plug that in. So this is the limit definition. Okay. I will give the limit definition to you on the test, but you've got to be able to use it. So f prime of a is the limit as h goes to 0, f of a plus h minus f of a over h. In this case, a is equal to what? A is equal to -3 in this case. So here's what I have. What is f of -3 plus h? Well, that's 2 divided by 5 minus h. What's f of -3? 2/5, so minus 2/5. Okay, so just stop right there. If I try and plug in h equals 0 there, obviously 0 in the denominator, and I'll have 2/5 minus 2/5. I'll have 0 in the numerator. So that is the indeterminate form, 0 over 0, which means we've got work to do. Does not mean the limit does not exist. So I want to simplify this expression. And the way I'm going to do that, I did this in the lecture video, so please make sure you watch my examples there. I'm going to multiply by the least common denominator of all the smaller fractions in the bigger fraction, right? We've got a compound fraction here. You can think about h as being over 1 down here, so it's really a fraction down here too. But all these denominators, 5 minus h, 5, and 1, what's the least common denominator? Well, obviously it's just the product 5 times 5 minus h, right? There's no common factors there. So I'm going to multiply the top by that LCD, and of course I have to do that to the bottom. So the net effect is I'm multiplying by 1. Right? Important that I'm multiplying by 1. So down below, I just get h times 5 minus h, or 5h times 5 minus h. So the bottom I leave that way. And I'm not going to distribute this 5h through. I want it factored, right? I want this to be factored. Now up top, I multiply this through. There's really parentheses here, right? And I distribute this whole expression through both of these terms. When I multiply this expression by the 2 divided by 5 minus h, the 5 minus h factors cancel, and I'm left with 2 times 5, which of course is 10. And then when I multiply this times the 2/5, the 5's cancel, and I've got -2 times the quantity 5 minus h. So I get rid of all, there should be no fractions within fractions now. Again, I still can't plug in directly, but I can simplify the top. 2 times 5 is 10. And then I distribute this -2 through. -2 times 5 is -10. -2 times -h is +2h. But the 10 minus 10, of course, is 0. So I'm just left with 2h up top. And now, finally, I've got it completely simplified and factored. I have that common factor of h. So I can simplify, right? Divide numerator and denominator by h. And now what's left over, 2 divided by 5 times 5 minus h, that is continuous at h equals 0. I can plug in h equals 0 directly, and I get 2/25. So there is the derivative of the function f at -3, 2/25. Now, we're to find an equation of the tangent line to the graph of the function f at t equal -3. So remember the equation of a line. Notice our independent variable here is not x, but it's t. So your function should be y as a function of t. So in that case, the point slope form of the line is y minus y1 equals m times the quantity t minus t1. And so what is m? That's the slope of the function at -3, the derivative, which we just found. It's 2/25. And what's the point? Well, it's at -3 comma f of -3. And if you remember up here, we said f of -3 was 2/5. So it's at the point -3 comma 2/5. So I just plug into here. I've got m. This is my t1. This is my y1. So it's y minus y1 minus the 2/5 equals m, which is 2/25, times the quantity t minus t1 is a -3. This becomes t plus 3. And now I want to solve for y, right? That would be ideal to get y as a function of t. So I'm going to distribute the 2/25 through, t 2/25 times t, and then 2/25 times a positive 3, 2 times 3, 6/25. And then to solve for y, I'm going to add 2/5, which is the same as 10/25, right? 2/5 is 10/25, multiply top and bottom by 5. So 10/25 added to 6/25 is a total of 16/25. Oops, I'm missing my little plus sign here, sorry. That makes all the difference in the world. So 2/25 t plus 16/25, that is the equation of the tangent line in this case. Okay, I hope this is helpful for you. Again, if you're having any difficulties with this, please let me know.